Probability of winning is 0.4. Probability of losing 0.6. Really good. Like that part. This is question 17. But what we need to work on now is what's the probability of winning at least once? So probability of winning at least once in 4 tries, I guess. Okay, that could be you won the first game, right? Or the second game, or the third. But it couldn't also be you won 2, you won 3, you won 4. So we are going to find the complement of that event. So what's the probability, the opposite of winning at least once?
Losing.
All the time.
Yeah.
Right? Okay. So that means you lose all 4 times. Now we can find this probability because this only happens once. You lose, times you lose, times you lose, times you lose, which is exactly what you told me. That's my picture,
the power of 4.
To the power of 4. And I don't know what that answer is, but you may have it.
0.1296. That's the losing.
Looks good. I agreed. Now, if the question had been, what's the probability that this poor person loses every single game, all 4 games, you would have said it's this. But remember, the only reason we found the complement was to allow us to get this guy. So you don't take the 0.4 to the power of 4 and the 0.6 to the power of 4 and add it. It's one take away the complement. We're doing that thing.
So I only have to, so it's one take away the complement?
Yeah. Yeah. If I was writing this down as a formula, the probability of an event is one take away.
4 losses, and I'm taking out one of my losses for the win?
No, what you're doing is you're taking out the probability that you lose all the time from 1. And what that's leaving behind is all the times that you didn't lose 4 times. So that's going to have you lost only once or twice or 3 times, or you didn't even lose at all.
So couldn't you do that as the 0.6 to the power of 3 instead of 4?
No, because that would just give you one particular situation. But there's lots of situations. You could lose and then win 3. You could win, lose, win 2. You could win, lose, lose, right? All of those events count as winning at least once. So it's just like that earlier question where we found the probability that it rained all 4 days, so that we could find this one, the at least. So whenever you see the at least, it's one take away the complement, right? It's one take away the complement. And the complement of winning at least once is you lose all 4 times.
And that's where the 0.8704 came in.
Correct.
So I took this and I did 1 minus. I'm making my notes here to make sure.
Sure.
Because that answers if I won, that I could win 1 time and it wouldn't matter what game I won, as long as you're showing that it's 1 game that you could win at least once.
Yeah, but you could win twice or 3 times, and that would also count, wouldn't it?
Yes.
Winning at least once doesn't mean that you win exactly 1 time. It could mean more than that as well. Which makes that a much more difficult probability if you try and do it by finding all the answers and adding them up, because there's far too many answers to find. So when you see an at least question, at least once question, think about the complement event, calculate that and subtract that answer from 1, and that's how you can do a short circuit and get the answer to complicated probabilities, right? Using the complement event trick.
Oh, that makes sense. Okay, now I'm looking at the next one, which I think I did the exact same problem with. I figured out what the table of customers would be, but I did not do the complement. I figured out what that power to it would be for the other. So I would need to do the complement first.
Okay, so if I recollect, is that another one of them? What's the
Yeah,
probability
this one's
that
the
she gets at
waiter.
least one big tip?
Yeah, one big tip. It's like 0.24 on this one. So
Right,
I
so
would
you're
take
going to
the
find that she doesn't get
one-
any good tips.
Yeah, so I would do the automatic where I do the 1 minus the amount of tips to come up with that. And then, so that's my complement. So my complement is 0.76. And
But
then
How
if
many
I
times?
got,
How many tables? Was it 5 tables in this
yeah,
story?
5, so I would take the 0.76 to the power of 5.
That's it.
And then then that gives me the 0.2535. And if I round that to a 6, so I don't have to write every single number down. Okay, and then, so for this, I would want to do the same thing. I would do it again. I would take the 1 minus the 0.2536 to answer.
You've nailed it, Tara. Right.
What?
Now, that thought process that you described to me is the exact thought process, the process that you should be using in these probability of something happening at least one questions, right? So you see that phrase, you're going to be thinking, oh, I'm going to do it like I did the casino game. I'm going to do it the same way I did with, I can't remember the other question, children in the family, or getting a big tip when I worked in a restaurant, or whatever it might be. The thing that they all share is that at least once part.
Got at least once, and it doesn't specify it, which seems, some of them make sense how they come up with the answers that they come, like the answers really make sense, and other ones it's like, I don't know, it seems